Consider the complex numbers. Z1 is 2 root 3 e to the I 3 pi on 2, and Z2 is equal to negative 2 plus 2 root 3 I. Write down Z1 in Cartesian form. So, for A part 1, we know that here in exponential form, we can write that into cis form as 2 root 3 cis 3 pi by 2, and that means 2 root 3 cos 3 pi by 2 plus I sine 3 pi by 2. Now you should know that cos of 3 pi by 2 is 0, sine of 3 pi by 2 is negative 1. So this will be negative 2 root 3 I. Now for part 2, which says express Z1 plus Z2 star, that's the conjugate, in Euler form. Well, Z1 plus Z2 star is going to be negative 2 root 3 I, take away 2 plus 2 root 3 I star, which is just negative 2 star. Well, the conjugate's only going to affect an imaginary part, not the real part. So that is just negative 2. And if we think about where negative 2 is over here, the angle there is pi. So that is 2e to the I pi. Okay, moving on to part B. B part 1, write down Z2 in modulus argument form. So for B part 1, well, let's make ourselves a little diagram. And our complex number is negative 2 plus 2 root 3 I, which will be over here. So that is 2, and that is 2 root 3. And so the modulus of Z2 is the square root of 2 squared plus 2 root 3 squared. And that is the square root of 4 plus 12, which is root 16. So that is 4. And arg Z2, well, we know that's root 3, or 2 root 3 divided by 2 would be root 3. So the inverse tan of that tells us that this is pi by 3, and therefore the argument here is 2 pi by 3. So that is 2 pi by 3. And so that is going to be Z2 is 4 cis 2 pi by 3. Hence, solve the equation z cubed equals z2. So, for B part 2, we have that z cubed is equal to negative 2 plus 2 root 3i. We can say that that is 4 cis 2 pi by 3 plus 2n pi for n belonging to the integers. Using de Moivre's theorem, z then is going to be 4 to the 1/3, the cube root of 4, cis, so we take the cube root of the modulus, but we divide the argument by 3, so that gives me 2 pi by 9, and then it will give me 2n pi by 3, which I'll write as 6n pi by 9, so I have the same denominator. And then it's just a case of picking out the ones that are between negative pi and pi, which is the usual way to go. Or you might go from 0 to 2 pi. So if we have, let's do it from 0 to 2 pi. It's not the usual way, but that's fine. And so let's say that this is the cube root of 4. And if n is equal to 0, we get cis 2 pi by 9. And with n equal to 1, we'll have 2 pi by 9 plus 6 pi by 9. So we'll have cube root of 4 cis 8 pi by 9. And then let's take n equal to 2. If you wanted to go between negative pi and pi, you take n equals negative 1. And that will then be the cube root of 4 and cis. So this would then be 12 pi by 9, so it will be 14 pi by 9. So moving on, let W be equal to Re to the I theta, where R is a positive real number and theta is between 0 and 2 pi. Find the possible values of R and theta if W squared is equal to 2 plus Z2 squared. Okay, so W squared is going to be 2 plus negative 2 plus 2 root 3i squared, which is 2 root 3i squared, which is negative 12. 2 times 2 is 4, root 3 times root 3 is 3, and then I squared is negative 1. So that would mean that W is positive or negative root 12i. Hence, R is equal to 12, and theta would be pi by 2, or 3 pi by 2, because this is purely imaginary, and so we would be here or here, so this is pi by 2, and then if we go all the way around, that is 3 pi by 2. Finally, we have part D. Find the smallest positive integer value of n for which z1 over z2 to the power n is a positive real number. So let's think about z1 divided by z2. We know from earlier that z1 in cis form is 2 root 3 cis 3 pi by 2. And also from earlier that z2 is 4 cis 2 pi by 3. So if we're dividing there, we are going to get root 3 on 2 cis, and then we need to subtract these. 3 pi by 2, take away 2 pi by 3, is 5 pi by 6. So z1 over z2 to the n would be root 3 on 2 to the n cis 5n pi by 6. Now we need the imaginary part to be equal to 0. That means that sine 5n pi by 6 would be equal to 0. Now, since we know that the sign would be 0 here and here, then for n to be multiples of 6, this would be true. So we'd have things like 6, 12, 18, and so on. But we have the stipulation that overall it needs to be real and positive. So we're only interested in here. If n equals 6, that's 5 pi, which would put us on this side. So the smallest one that's going to put us on this side is when n is 2, and therefore what is in here, n is 12, would give us 10 pi, which is over here. So it's going to be n equals 12 for z1 over z2 to the n to belong to the positive reals.